All right, welcome back, everyone. We are going to learn about Newton's third law of motion today. Um, we're both happy to be here.
Yeah.
Excited. Okay, let's get to it. So, the third law of motion states that for every action, there is an equal and opposite reaction force. So, let's talk about what that means. The action is a force exerted by one object onto a second object. The reaction is an equal and opposite force exerted from the second object back onto the first object. So we're going to go over some examples on one of the next slides. It's going to make a little more sense then, I think. How can the reaction be equal and opposite? Because that's kind of confusing if something's equal and opposite. But remember, these are vectors. So because they're vectors, they are equal in magnitude. Hopefully you can read that. Equal in magnitude, but they're opposite in direction because vectors have both magnitude and direction. So it's equal in the size of the force, but the direction is the opposite direction. So this is very important, definitely on the test. Basically, it's the summation of the third law. It says action and reaction forces are always equal. So write that big in your notebook. Highlight it, circle it, put stars, put glitter around it so you will not forget that. Action, reaction forces are always, always, always equal.
So some examples of Newton's third law. The wings of a bird push air downwards, and in turn, the air reacts by pushing the bird upwards. So that kind of makes sense. Another example is a hammer and a nail. The force that drives the nail is the same as the one that stops the hammer. And then the last example we have is when you push on the wall pushes on you. Otherwise, you would fall down. Another example would be jumping. If you jump and you have a force, you exert a force on the earth also exerts a force on you, or you would fall through.
All right, question 1. A Volkswagen Bug is driving east and a living bug is flying west when they collide. So we have two things going to collide. Is the force on the car bigger, smaller, or the same as the force on the bug? Think about it and put down your answer. What do you think? All right, so the answer is
Force is the same on the bug and the car because, that you already wrote down, very big, action and reaction forces are always equal. Super important.
yes. And students always get this wrong because they think the car is going to hit the bug harder. Not true. They hit each other with the same force. Question 2. Is the acceleration of the car bigger, smaller, or the same as the acceleration of the bug? We didn't talk about this, but if you think about what's going to happen to their accelerations, which do you think is going to have a bigger change in velocity? The bug, the car, or will they be the same? Go ahead and answer this question. The answer to this one is the car has a smaller acceleration because it only slows down a little bit, and the bug has a greater change in speed, and that's because their masses are different. All right, and that is where we're leaving off for today. Next class, we're going to discuss Newton's third law in some detail. We have some demonstrations, which are going to be exciting, and we'll have some more discussions around that. Looking forward to seeing you guys soon.